In this video, we're going to explore taking derivatives using the chain rule a little bit more. Here, we're going to differentiate y equals 4 minus 3x squared to the 9th. So looking at this function, this is not just x raised to the 9th. We can't directly use the power rule. If we also consider trying to multiply this out, we don't want to do that. That would be 4 minus 3x squared times 4 minus 3x squared times 4 minus 3x squared. Do that 9 times, that's going to be huge. So this is a situation where it's really ideal to use the chain rule. So notice I have an outside. I have something raised to the 9th. And I can look at this as being a composition 4 minus 3x squared. Okay? So the derivative of the outside, the derivative of y with respect to x, is equal to 9, whatever we have in there, to the 8th, times the derivative with respect to x of the inside. Okay, so I'm looking at this like I have an inside. I'm writing it using more notation than one might need to try and help you see what's going on. We have an interior function, and then we have one on the outside. So in this situation, as I simplify, that's 9. My inside function is 4 minus 3x squared, all of which is raised to the 8th, times the derivative of the inside. And my inside is 4 minus 3x squared. So when I take that derivative, the derivative of 4 is 0. The derivative of negative 3x squared gives me negative 6x. So my final step here, the derivative of y with respect to x, the 6 and the 9, I'll multiply these together. I've got negative 54x times 4 minus 3x squared to the 8th power. That is our answer, finding the derivative using the chain rule, which is surely much easier than multiplying this, foiling that out 9 times, and then taking the derivative. All right, so let's do 1 or 2 more examples here using this basic chain rule property. For this example, we're going to differentiate q equals the cube root of 2r minus r squared. All right, so dealing with a cube root, one thing we would often do, we'll say we're going to rewrite this, and that is 2r minus r squared to the 1/3 power. So if I'm to take the derivative of q with respect to r, all right, we look at our variables to pay attention to our notation. So here I have an outside and then I have an inside. The derivative of my outside is 1/3 of that inside. That would be to the 1/3 minus 1. And 1/3 minus 1, 1/3 minus 1, gives us negative 2/3 as my power. Okay, so I have my inside. And then I have to say, well, times the derivative of my inside. So we have 1/3, and that is 2r minus r squared to the negative 2/3, and the derivative of my inside, that's the derivative of 2r minus r squared. The derivative of 2r is 2, and the derivative of r squared is negative 2r, minus 2r. All right, so we're done taking the derivative. At this point, we just take another step or 2 to clean it up. So the derivative of q with respect to r is, now 2r, or 2 minus 2r, this piece doesn't have a negative exponent. So I'm going to slide that into the numerator. And then my 3 is in the denominator, this 3 right here is in the denominator. We have 2r minus r squared. That would be raised to the positive 2/3 power if I moved that to the denominator there. All right, so that's my final answer. I could, if I wanted to, rewrite that using a radical instead of a rational exponent. So this is the same as 2 minus 2r over 3 times the cube root of 2r, I need parentheses there, 2r minus r squared squared. So that would be the same.